So today we're going to be proving the quotient rule for calculus, and we use that every time we're differentiating a rational function. The proof for the quotient rule is actually a result of the chain rule and the product rule for calculus. So if you want the proof of those, you can look in the description. Anyway, so the product rule is when you differentiate f of x times g of x, you get f prime of x times g of x plus f of x times g prime of x. And the chain rule is if you differentiate f of g of x, you get f prime of g of x times g prime of x. So let's start with the derivation. If we want to differentiate f of x over g of x, well, this doesn't look like a product, but if we rewrite this g of x as g to the power of -1, then we would have a product rule situation. Now let me remind you that g of x to the power of -1 is also the same as writing 1 over g of x. Because if you have a negative exponent, you've put it in the denominator. So let's write it. If we want to find a derivative of that, we get f of x times g prime of x to the power of -1. And we want to find a derivative of this. Okay, so if you want to find a derivative of this, let's use the product rule. So let's differentiate the first term, so that's f prime of x, and then g of x stays the same, so that's times g of x to the power of -1. And we add it by f of x, now we take the derivative of g of x. Now, this is g of x to the power of -1. So in this case, we would actually have to use the chain rule. So this actually has two different functions. There's a g of x and there's a power of -1 here. So we have to use the chain rule. So all we have to do is move this to the front, and we have to subtract this by 1. So we get negative g of x to the power of -2. And now we take the derivative of the inside, which is just g of x. So this is times g prime of x. If we rewrite this equation, instead of having these negative exponents, we would have f prime of x over g of x minus, because we have this negative here, f of x times g prime of x all over g of x squared. And there we go, we have our quotient rule. But I'm pretty sure most of your textbooks don't write it like this. But it's actually just one step more to put it into the format that we all know it as. We just multiply the left term by g of x over g of x. And the reason why we can do that is because this just equates to 1. So we're not changing the value of this expression in any way. So our final expression is f prime of x times g of x minus f of x times g prime of x all over g of x squared. And that is the quotient rule. So now that we have the quotient rule, we can use that to derive the reciprocal rule. So let's say we want to differentiate this function, which is 1 over h of x. Now notice that 1 over h of x is just a reciprocal function. So the top part is just 1, which is a constant, and the bottom part is h of x, which can be any function. It can be a polynomial function, it can be a trig function, or whatever it is just a function. And all we have to do is just plug this into this formula. So let's do that. So if this is f of x and this is g of x, let's plug this in. So we got f prime of x, the derivative of 1 is 0, so that's the first part, 0, times g of x, which is just h of x, minus f of x, which is just 1, times g prime of x, so the derivative of g prime of x is just h prime of x, all over h of x squared, since h of x is g of x. So h of x squared. So let's just simplify it. 0 times h of x is just, well, 0. So this entire thing can cancel out. And 1 times h prime of x is just h prime of x. So this kind of disappears as well. So our final formula is negative h prime of x all over h of x squared. And that is the reciprocal rule formula.